Next page. Same directions. I just wanted to do a couple more examples to see, well, what's going to happen with this function. So Audrey, what would my amplitude be for 4 times sine of 1/2 x? Yep. Amplitude equals 4. How would I find my period? Ezrin, what would I have to do? Yeah. So 1/2 is my b. So I'm going to do 2 pi divided by 1/2. But that's the same as 2 pi multiplied by 2. When you divide by a fraction, you have to multiply by the reciprocal. So 2 pi divided by, or 2 pi multiplied by 2 is 4 pi. So in this case, my period has gotten bigger. And that should make sense to you. From transformations, we know if we multiply by a fraction inside, I shouldn't say fraction, by a number smaller than 1, we actually get a stretch. So it's like opposite of what you would think. Whereas earlier here, we multiplied by 2 inside with x, and our graph shrunk horizontally. This one is going to stretch horizontally. And then that's all we need to at least get started. Where does the sine function start? Where's its like y-intercept, I guess? If I plug in 0, what do I get? 0. And you're going to do great at this. We need to remember sine is starting at 0, 0. Cosine starts at its maximum and then goes from there. Okay, so in this case, sine function starts at 0. I'm going to try to graph this one without graphing the parent function. Okay, first. We know we have to do a period every 4 pi. And so I'm going to just go by pi's here. I'm going to do 2 tick marks is pi. So this other 2 tick marks is 2 pi. Can you guys read this okay? I feel like it's sort of, that graph is so bold. 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. That'll be good. That will give us 2 full cycles, or 2 full periods. Okay. If I know that this has to go through a whole cycle in 4 pi, I'm going to think up here about sine function. It goes up, down, and back up, and that's 1 period. And that 1 period has to be at 4 pi. So if you think about splitting that into sections, these other numbers will occur at all the other pi's, because this middle halfway will be 2 pi. Halfway between 0 and 2 pi will be the 1 pi. And so I can graph this as pi will be my maximum, which has to be an amplitude of 4 units. So 1, 2, 3, 4. 2 pi will be a 0. 3 pi will be negative amplitude. And 4 pi I will be back to 0 again. And that completes my 1 period. So for those of you who are very visual, you can see that what we did was we took our period. There's 4 important sections that we need to think about here. So you take your period, divide it into 4, and that's where you make your important points. And then we can continue. What's going to happen at 5 pi? Yeah, I'll be up at my maximum. What's going to happen at 6 pi? At 0. What about at 7 pi? And what about at 8 pi? 0 again. So there's my second period drawn in. If I wanted to go into the negatives, what's going to happen at negative pi? Yeah, down here. And then back up at negative 2 pi. And it could continue, but we don't have enough space. Okay? What's different about the next one? Yeah, there's a 3 pi multiplied inside. It works the same. It's just that when we graph it, you're going to see what we put on the x-axis is different. Let's calculate and look at some of those important things, though. Brittany, what's my amplitude going to be? 1/2. What's my period going to be, or how am I going to figure it out someone I haven't called on yet. Gary. Good. Notice the whole 3 pi is my b, whatever's multiplying by x. And so my period will be 2 pi divided by 3 pi. So really, just 2/3. That's not going to be that fun, but it will be because we can label our graph any way we want. So you'll see that it's not too bad. What I want to write down, though, just because this is a little different for us, this means that it goes through one cycle in 2/3 units. So what I'm going to do to be strategic on my graph is I'm going to graph out where I want the 2/3 to be. So how did I do this? I went 1, 2, 3. I made the 4th tick mark 2/3. Why did I do that? Because we know sine and cosine functions, we know it's easy to split it into fourths because those are where our important points occur. Now, where does the cosine function start? If I plug in 0, it starts at its maximum. So sometimes at 1, but in this case, our amplitude is 1/2. So it starts at 0, 1/2. So I'm going to label this point right here as 1/2. We know that's where it starts. Where does the cosine functions, where does one period end, is back up where it starts. And what happens in between, if you look at your parent function for cosine, is in the very middle. In the very middle of one period, you have your lowest point. So the very middle of this graph, which will be right here, is going to be a negative 1/2. And then exactly in between will be our x-intercepts, here and here. And there's one cycle for this function. And then I could continue that out. Down, minimum, 0, maximum. 0, minimum, 0, maximum. Good enough. Any questions on that? Yes, sir.
I'm just curious why you placed your 2/3 so far away.
I guess because I wanted to be able to use it. So the question was why we placed the 2/3 so far away. Was because I wanted to be able to go through those like 4 sections, and I wanted it to be easy to graph. Does that make sense? So if I had actually placed like 2/3 where I think 2/3 would be, then it'd be like harder to make that sketch as accurate as possible. And so the cool thing about these graphs is you can, unless I provided you with a graph to draw on, you can make your axes whatever you want, and then it's a little bit easier to graph. Does that make sense? But yeah, normally, I mean, if I had made this like each box represented 1, then the 2/3 would be, I mean, like, so if this was 1, 2/3 is here, so your cycle would be like that, right? Like super tight and close. Oh, no, so this would, right here would represent 1/3 if you want me to label it, yep. And so I'm actually going by 6ths, yeah. All right, this is one other example I think we're going to do today, and then I'm going to let you practice some of the stuff we've done so far, and we'll come back on Monday and do phase shifts. So this one is, how do I just work backwards? How do I write an equation for one of these functions given the amplitude and given the period? The amplitude should be the easy part. The period, it takes a little bit of work. So for this one, it says we want an amplitude of 2, and we want to write it for... Oh, I'm missing something. This should say y equals. You don't know why that did that. It says write an equation of the form y equals something times sine of b times x, where a is bigger than 0, b is bigger than 0. So the graph has the given amplitude and period. So we want to say y equals 2 times sine of bx. We know the 2 because the amplitude has to be 2. The period, you could look at some of my other problems. When did we end up with a period of pi? What did we have to put in for b? 2. But if you don't want to look at another problem, or if it's something harder than that, what you do is you say, oh, hey, I know period has to equal 2 pi divided by b. And in this case, my period is supposed to be pi. So I'm going to plug pi in there. Pi equals 2 pi over b. And then I'm going to solve for b. Well, or think about it in your head. 2 pi divided by what is pi? So b is 2. But if it wasn't that easy, you would multiply by b. And then divide by pi to get your b alone. So b would equal 2 pi divided by pi, which is just 2. So that's like the math behind where it comes from. So then y would equal 2 times sine of 2x for that problem. Who when I talk? Lane, what about for the next one? How would I make it so that y equals whatever to make an amplitude of 0.5? Sine of, and we're going to make this just bx for right now. Okay. To find my b, I'm going to write an equation, period equals 2 pi divided by b. What I didn't realize is b's look like 6's, so your notes might not make a lot of sense. The period is supposed to be 6. So this is one where I think you actually do have to multiply. Thank you, Cole. Multiply by the b to get it out of here. So then b times 6 equals 2 pi. Divide by 6. So we get b equals 2 pi over 6. What does that reduce to? 1/3 pi. So I'm just going to write pi over 3, which is the same as 1/3 pi. So when I write my equation, y equals 0.5 times sine of pi over 3x. Okay? And that's where we're going to end for today. Your homework for today is going to be, you'll need some graph paper, so I'll pass that out in a minute. In fact, can you pass one of those out to everybody? And write it on here. So this is, if you could call your assignment 9.4 Part 1. It's page 491, numbers 5 through 11 odd, 14 through 18 even, and 22, and 15. So that's out of order, sorry. Um, 14 through 18 even, but also 15, so you can put it in whatever order you want. And then 22. And we're going to stop there for today.